Okay, what we have here, this is not a part of the Eccles Rail Center, and you won't see this parked here all the time. You can go over and watch them over at the Frontrunner station, but this is an MP36 locomotive. It's actually a hybrid rebuilt locomotive. There never was a brand new MP36. MP36s are made by Motive Power Industries. Used to be old Morrison Knudsen Construction Company, who started rebuilding diesel engines in the late 1960s on the outskirts of Boise. What Motive Power does, they take components from older locomotives they buy at scrap prices. They remanufacture those components and make totally new locomotives out of them that oftentimes bear a little resemblance to whatever existed before. This engine has the General Motors Blomberg-style wheel set, or truck, as they call them, that probably came off of a 1970s vintage freight engine. Remanufactured, it's got newer components on it. Things like that will last indefinitely unless they develop a structural crack, and they always x-ray for that. The underframe is a combined from other locomotives, but what they're doing is they're using it to build a larger commuter rail locomotive. That this type of engine is used on several commuter train systems. They have them in Southern California, they've got them in the San Francisco Bay Area, etc. They use engines like this up in Canada also for commuter trains. This is called a builder's plate, something that diesel engines have had for decades. Steam engines had something similar to this, but builder's plates, they weld them on now because train buffs were always taking a crowbar and pulling them off. But it tells the type of engine. This has a BB wheel arrangement. Diesel locomotives, since every axle is powered on your modern diesels, they have an alphabetized system versus a steam locomotive having 484. Well, this is BB. 2 axles means a B-type truck. If it had 3, like a lot of the freight engines we see here, it would have a CC wheel arrangement. It tells how much it weighs, 288,000 pounds. Actually, this is a fairly lightweight passenger locomotive. The freight locomotives are around 430,000 pounds, heavier for more pulling power. It's got horsepower, 3,600, and it was built in April of 2007 for Utah Transit Authority. But that's what this engine is. It's the standard motive power of the Frontrunner fleet. Now, some of the other things I'll point out, you've got a snowplow pilot on the front. They do not call these cow catchers. Cow catchers are on choo-choo trains. Okay? The front of the engine is called the pilot beam. Most locomotives today have a snow removal scoop on the front called a snowplow pilot. Obviously, the coupler, the 480 volts is where you would plug this engine in to provide power to the passenger cars in front or behind it, and that's 480 volts alternating current. The actual locomotive developed 600 volts direct current to make the propulsion system, the traction motors on the axles, move the train forward. This is just what it looks like. It's a shock absorber, though the railroad terminology is a snubber. This is a speedometer cable coming up. This is flat leaf springs here on the actual truck system itself. And if you lean over, you can look in and actually see the big box with cables going to it. That's the electric motor. There's a pinion gear coming out of the motor, and it's connected to a bull gear on the actual axle, and that's what makes the train go. There is no connection between the up and down motion of the pistons or the rotation of the crankshaft and the wheels. Not like a truck or a bus. It's diesel electric. It's an electric locomotive that generates its own power rather than having overhead wires. Back here, you've got your main air reservoirs for your air brake system on the train, piping associated with it. And when you listen to these engines when they're operating, you'll hear them making a spitting sound like that. That's the moisture separator getting moisture out of the air brake lines. You don't want to have moisture. You compress air, it compresses the moisture in it. You've got to get rid of that or you have freezing problems in the winter. Here is your fuel filler. This is your fuel tank right here. Has a capacity of, it looks like about 2,300 gallons of diesel fuel. You billet here, and this is a visual sight glass. So you can manually see, without having to use any gauges, how much fuel is actually in the tank. This part of the locomotive right here, you can see the big steel structural member. There are twin I-beams that make up the underframe of the locomotive with connection beams across them. This is the structural support system of the locomotive. Unlike the old-time streamlined diesels of the 50s, where they had a cantilever, like a a bridge structure in the body of the engine, the upper part of the engine is strictly decorative and is not a part of the main structure of the locomotive. The underframe carries all the weight. Yes.
Sand on it? Has the sand on that, on the front truck?
Yeah, I'm going to show that
okay.
back
I don't know if I had one back here too.
Yeah, there's always one front and back. You know, on steam locomotives, up on the boiler, you see these domes on the top. One of those catches the steam as the water boils. Another one carries sand to keep the wheels from spinning. But you know what? Even in 150 years later, they still use sand to keep the wheels from spinning, though they also have electronic wheel slip control devices. You do not want to spin your wheels with a diesel engine because of the amount of weight. Unlike the big steam engines that would do that, when a diesel spins its wheels, it peels a layer of steel off the top of the rail. Looks like a carrot curl. That creates a flat spot, and over time, the passage of millions of wheels going over at its speed, those wheels bang down slightly, they induce metal fatigue, and fatigue fracture cracks in the rail, and that can lead to a derailment. So wheel slip control is very important, not only to protect the rail, but to give the engine more actual pulling power. Here is the sand tube. See the nozzle right down there in back of the wheel. You always have one in front and in back, depending on which way the locomotive is going, should it be in a multi-locomotive consist. But the sand is carried up here. If you look, come on down here, see the notch in the hatch right below the number 5? Usually they carry several cubic yards of sand, front and back, in every diesel electric locomotive. Now, steam engines carried them too, but the sand was up on top of the engine in a big dome and had piping just like this and went down the wheels. Brake shoes used to be made of iron, but they tended to glow red hot, pulling a heavy freight train back on a grade. After World War II, they began to develop what was called a composite brake shoe. Like the brakes on your car, the brake shoe will slowly burn off over time. They have to be replaced, and they're not lightweight. They're very heavy to replace those brake shoes. Don't ever try to use one as a doorstop like a friend of mine did. Just the same, the brake shoes will burn off over time, and they tend to burn off cooler than the bright, red-hot iron brake shoes of the World War II era, for example. Now, hold on just a minute. We have a freight train coming through the yards. Hear that whining sound it's making? See it right through here. The whining sound is called dynamic brake. This engine has one. You've got your radiator grill on top, then right above the word front. In Frontrunner, see there's a different style grill with vertical fins. That's the dynamic brake resistor grid. Now I'll talk more about that when we get over to the Eccles Rail Center, okay? And over by the freight locomotive. This is a standard Bombardier commuter car. This type of car with the octagonal shape to it, where the roof line isn't uniform, it goes up and down. These cars were introduced in 1978 by the government of Ontario Transit System up in Canada, or what they call GO Transit. That's the commuter train system of the Toronto and Hamilton metropolitan area. This is today the standard commuter train car in all of North America except in the northeastern United States, where these full-height double-deck cars will not fit through the tunnels or under the electric wires. I don't know about you, but that's real important when you're sitting on the upper level, and 60,000 volts is a little hot for a wake-up call in the morning.
That'll make your box for it.
These cars are built to work in conjunction with elevated platforms. So the doors can open and a handicapped person in a wheelchair can roll right in. They have special seating on the upper level. The older style, what we call the Chicago gallery cars, first developed in 1950, like they have in Chicago, San Francisco, and other areas, they do not have handicapped accessibility with those cars. That's why that style is no longer made, and everybody buys the Bombardier cars. That's a Canadian company. They build those cars in Canada for all the commuter train systems around North America. Very good car. Okay, this is a cab car. Commuter trains in almost every city in the U.S. and elsewhere are what they call push-pull. A commuter train by nature is not a hugely money-making operation. Therefore, when you get to the end of the line, you want to be able to turn it around quickly. In the old days, they had to completely turn the train around on a Y track, like down at 31st Street. With cab car technology and push-pull operation, you don't have to do that. Frontrunner trains run cab car leading to Salt Lake, locomotive leading back. Some of the cables you see transmit commands from the cab in the cab car to the locomotive in the back. In other words, when the train is in push mode going to Salt Lake, the engineer right over there on the right side. No one's in the locomotive. It's being controlled by electrical multiple unit connections, just like they lash up diesel locomotives together on a freight train. This idea dates back to the 60s in Chicago, and it was later copied in other parts of the country as they went to double-decker push-pull commuter train operations. Notice it too has a smaller plow pilot on the front, because that would be the front of the train going towards Salt Lake. In Chicago, the cab car always leads coming into Chicago. The locomotive leads coming out. Now, since we have a unique opportunity here, let's all walk across the tracks, and you can see this operation as the train comes in across the flyover bridge over 31st Street Junction going to the north end of the line here. The reason that bridge was built, this is a busy rail junction. When I used to run Amtrak trains through here, sometimes we'd sit for half an hour down there waiting for a freight train to get out of our way so we could come from Salt Lake and come into the Union Station. The building of the bridge allows the commuter trains to literally fly over the freight train operations, and neither one interferes with the other. It's expensive, but it pays huge dividends over time. The freight train that we heard a few minutes ago with the dynamic brakes, that's the train sitting right there. The engines are down there, and they're changing crews at the Ogden Yard office right now before heading out across the Great Salt Lake. A combination of his air brakes and his dynamic brakes to stop the train. Dynamic brakes, when they were first developed in World War II on General Motors' first freight diesel locomotive called the Model FT, only were good down to about 15 to 20 miles an hour. Then in the early 1970s, GM and General Electric introduced what was called extended range dynamic braking. That was good down to 7 or 8 miles an hour. Now you can nearly bring the train to a stop on dynamics alone, but you still have to have your air brakes. Now let's move right around here. You don't have the sun creating a shadow effect. Passenger train cars today generally incorporate the two basic types of braking systems. You can see the class type brake right in here with the composite brake shoe, and then on this axle here you can see in this case an outside mounted disc brake. Disc brakes are great for slowing the train down at high speeds, but that last 10 to 15 miles an hour you'll use the class brakes to bring it to a stop. How we learned about that was when Amtrak came out with its double-deck Superliner cars about 32 years ago. We had nothing but disc brakes on those cars, but we began to shell out the disc brake rotors very quickly. We couldn't figure out why. And we realized that a disc brake, the way it works on a heavy rail car versus an automobile or a truck or a bus, the last 10 to 20 miles an hour tends to cause the brakes to shell. So all the superliner cars and all passenger cars since here in North America have been built with a combination. The discs are used for high-speed deceleration. The class brakes bring the train to a complete stop at the station. So, 8 questions so far as we go about looking at this. I'm not covering everything because I figure you guys would like to have dinner tonight, so I didn't want to take too much time.